Okay, so we're starting our studies of circles, and we're going to be doing circles and arc lengths, circumference, area, that sort of thing. So we're going to start with our arcs and some basic definitions of all of this. So we start with a circle. This is a set of all points equidistant from a given point. So here's my circle. There's some point in here called the center. And so all of these points on the circle are the same distance away from the center. A radius goes from the center to the circle, has an endpoint, one endpoint on the center, the other endpoint on the circle. There are infinitely many radii around a circle, and they all have the same measurement because they're all the same distance. That's what makes a circle so complete. I also put a little note down here. Congruent circles have congruent radii. If you have several circles and they're all the same size, they all have the same radii. All right, a diameter. It's a segment that contains the center of the circle and has both endpoints on the circle. So it goes through the center, both endpoints on the circle. And we know that the diameter is twice the radius. So depending on what they give you in a problem, you could convert to a radius or to a diameter depending on what they give you. Then there's also a thing called a central angle. These are angles whose vertex is the center of the circle. So I'm going to draw it in orange up here. So here is a central angle with the vertex on the center. And it just so happens that the measure of a central angle in degrees is the same as the measure of the arc in degrees. All right, a few more definitions. An arc is a piece of a circle. So it's just like you cut a big section out of the circle. That's called an arc. We also have a semicircle. This is half of a circle. So a semicircle is 180 degrees because it's half of a 360. Then we have a minor arc, which is smaller than a semicircle. So this would be less than 180 degrees because it's smaller than a semicircle. And then a major arc is greater than a semicircle, so it would be greater than 180 degrees. All right, so in this picture, let's just name a couple of these just to get us going. There's a lot, but we can just name a couple. So a minor arc, we're looking for something that's less than 180 degrees. So that would be AC would be one of them because it's a smaller arc that's less than 180 degrees. AD is also one. You could name DE as one. You could name CE as one. They all have less than 180 degrees, so they're considered a minor arc. A semicircle you have to name by three letters. So we could go A, D, E because that's 180 degrees. It's half a circle. You could also say ACE. That would be another semicircle. You could do CAD. That's another semicircle. One more would be DEC. I think there's four semicircles total in this picture. All right, in a major arc, we have to contain point A, and we're going to name it by three letters. So let's say we start at C. So we go C, A, E. So you start at C, go through A, all the way around to E. That is a major arc. You could start at D and go all the way to E. That would be another major arc. Anything bigger than 180 degrees. Okay, we also have something called adjacent arcs. Adjacent arcs are on the same circle and have exactly one point in common. You can add the measures of these just like we add adjacent angles. So if they're two arcs that are right next to each other, we can add them together and create a bigger arc. And there's a postulate for that. It's kind of like the angle addition postulate, except it's the arc addition postulate. So in order to get a larger arc, you're going to take a smaller arc plus a smaller arc. So if AB was 50 degrees and BC was 70 degrees, you would add those two together. So ABC would be 120 degrees. Okay, the measure of the arc formed by two adjacent arcs is the sum of the measures of the two arcs, sum being addition. All right, let's go through this example. Find the measure of each arc. BC has a central angle. Its central angle is 32 degrees. That means BC has to be 32 degrees. All right, then we look at BD. So all the way from B around to D, we're going to add those two together. So we're going to add 32 plus 58, and we get 90 degrees. Then ABC. If you look at ABC real close, you'll see that it's half a circle. So it's 180 degrees. And then AB is part of that semicircle, but not all of it. We're going to subtract off the 32. So you take ABC, and we're going to subtract off what we have in BC, and that'll leave us with what AB is, which is 148. All right, a formula that you definitely need to know, so you need to put a star by this or highlight it or whatever you need to do so you can remember it. The circumference of a circle is pi times the diameter. Okay, this is formula number one, pi times the diameter. We also can say 2 pi times the radius. This would be another formula. These are both the same formula, that's why there's an equal sign between them. It doesn't mean that you have to use both of them. You only use one or the other. You do not have to use both. So pick the best one for the situation. If the circle has the diameter, then you use the diameter. If the circle has a radius, then you use the radius one. Depends on what you have. Okay, so let's add a little bit to this because circumference isn't that difficult. You just plug things into the formula and you just go with it. Okay, so, but for arc length, let's say we want to find the length of AB in inches or feet or miles or something like that. To do this, you're going to make a ratio, the measure of the arc over 360 times the circumference of the circle. Now let me explain this a little further, okay? This part gives you a fraction of the circle. So let's say your arc is 90 degrees. Then if you do 90 degrees out of 360, that's a 1/4 ratio. That's a fourth of the circle. If you do 60 degrees out of 360, that would be 1/6 of the circle. So it's just a fraction of the circle, so however much of the circle you're dealing with. And then your circumference, you either use pi times diameter or you use 2 pi r. Depends on what you're given in the problem that determines which one of those you use. Okay? And this whole thing, when you multiply it out, gives you the length of the arc out here. Alright, so let's try this. We're going to find the length of xy in inches because that's what's in our problem. The 16 is the diameter, and we have a 90 degree right here. So we're going to do 90 degrees out of 360 times the circumference of the circle. So we do pi times diameter because they gave us diameter. So that would be 16 pi. Okay, so when we do math to this, 90 over 360 reduces to 1/4. You type that in your calculator or you just do it in your brain. Either way, you should know that is 1/4. So then we do 1/4 of 16 pi. That's 4 pi. And we put inches for our units. If you need a decimal for this, then you type it in your calculator and you hit the double arrow key and get your approximation. Alright, same deal with this one. We want to find the length of xy. It would be in centimeters because that's what's in our problem. The 15 is our radius. And then they give us this 240 degrees, which would be all of this arc down here that's kind of highlighted in red. So knowing that we know that a circle is 360 degrees, we can take 360 minus 240 and get xy to be 120 degrees. And that's kind of helpful because that has to go in our formula. So we do 120 out of 360 times the circumference, and with this one we have a radius, so we're going to use the radius. So we double it and get 30 times pi. Alright, reduce 120 over 360. That gives us 1/3. So then we do 1/3 of 30 pi, and we get 10 pi centimeters. Alright, and that is it for section 10.6.